Eagles, Mrs. Ryan here. We are on our Associative and Distributive Properties of Multiplication practice page. You should have just watched the first video, and there were a few questions inside of that video, so make sure that you answered those. If you missed them, then you should go back to the previous video and listen and answer those questions. So now you're here. Yay! Practice with me. Just like before, with the other two properties, we are going to fill in the definition of the associative property. The associative property. So the definition is the product. So hopefully you remember product is the answer to a multiplication problem. Like this down here, that blank, because it's this is multiplication equals, this would be our product. You don't have to write that here. I just wanted to make sure you remembered the answer to a multiplication problem is called a product. The product of a set of numbers is the same no matter what their order or grouping. So this is similar to the commutative property. When we have two numbers, it doesn't matter which order the two numbers go in. Well, associative property, it doesn't matter what a set of numbers, so more than one or more than two numbers. That's why we're going to be working with threes. It doesn't matter what order the digits go in when we multiply. Okay, let's start with our examples. So our first set of examples are pretty straightforward. We're just going to read our equation from left to right like we normally would. So 2 times 3 is 6. 6 times 4 is 24. So we would just write 24. Now, on the second equation, the numbers are mixed up. This goes 2, 3, 4. This goes 4, 2, 3. Well, 4 times 2 is 8. 8 times 3 is 24. So you'll see that we get the same product, no matter the order or the grouping. 5 times 2 is 10. 10 times 1 is 10, because the identity property, do you remember that? Anything multiplied by 1 results in itself. So 5 times 2 is 10. 10 times 1 is 10. 2 times 1 is 2. 2 times 5 is 10. Let's look at number 3. 3 times 6 is 6. I was about to say 16. 3 times 6 is 18. 18 times 2 is 36. 6 times 2 is 12. 12 times 3 is 36. Okay, now let's look at our next set or grouping of practice examples, 4, 5, and 6. You'll notice that now we're working with parentheses. Now we're working with parentheses. The rules of math indicate, if you don't know this already, that anything in parentheses has to be solved first. So anything inside parentheses must be solved first. So let's use that rule. And now let's keep going with 4, 5, and 6. So we always have to start with the parentheses. So 6 times 2 is 12. 12 times 4 is 48. 2 times 4 is 8. 8 times 6 is 48. And again, we have to start with our parentheses. So even if our parentheses were over here on this side, we would have to start with those parentheses. So 8 times 2 is 16. 16 times 1 is 16. 2 times 1 is 2. 2 times 8 is 16. Last one here. 5 times 3 is 15. 15 times 2 is 30. 3 times 2 is 6. 6 times 5 is 30. Yay! Now let's move on to 7 and 8. 7 and 8 have 3 digits or integers or factors. A lot of words here, right? A lot of math terms. They have 3 factors on one side of the equation. There's the equal sign. And 3 on the other side. We are going to prove using the associative property that these two sides of this equation are equal. So let's look at these. I'm going to zoom in a little bit here for you. I hope that helps. Okay. I'm going to erase that because it bothers me. Now remember, whatever is in parentheses, we have to solve first. Parentheses first. Okay. So here we go. Let's show our steps. The purpose of this is to show our steps. So 4 times 2 is 8. So we're left here with 8 times 6. Because 4 times 2 is 8. And then we're left with our 6. Now let's go to this side. Now we have to solve 2 times 6 first, because that's what's in parentheses. 2 times 6 is 12. That leaves us on this side with 4 times 12. Well, I know that 8 times 6 is 48. And I know that 4 times 12 is 48. There we go. Now let's do number 8. Again, whatever's in parentheses, we have to solve first. So the numbers are 253 and 253. They're the same numbers, but this indicates with the parentheses that we have to solve the numbers in a different order. So the first thing we have to do on this side is solve 2 times 5 because it's in parentheses. 2 times 5 is 10. So we're left with 10 times 3 on this side. And on this side, we have to start again with the parentheses. So 5 times 3 is 15. So we're left with 2 times 15. So now let's solve. 10 times 3 equals 30. And 2 times 15 equals 30. So we have proved that these are equal. Awesome. Now, if you flip your page, you'll see that there's a section called Now You Try. These are just like the ones on the previous page. So you can flip back and forth if you would like some help on how to set these up. So you'll see that number 1, just like the ones we first tried, there are no parentheses. You just solve it, and they should be the same answer. On number 2, there's parentheses in the first one, but not in the second one. So remember to solve the parentheses first. Make sure that these are the same product. Then, just like the 2 that we did last together, you're going to show the steps. You're going to show what happens when you complete the parentheses first, and then what each side would equal. Complete what the parentheses are first, and then what would be the product of each side. All right, and when you're done with this, you want to go back to the Nearpod so you can start the distributive property. Yay! Bye, everyone.